Okay, question number 8. We are estimating the integration by using rectangles. We're trying to find the area underneath the curve using the rectangles. So I've got two nice diagrams here where we use rectangles to estimate the area. Notice how I've drawn in diagram 1 the rectangles come in underneath the line, and the rectangles go above the line in the second diagram. Okay, I've marked the crosses on the line so that the widths along the bottom are 0.25 each. So this is 1.25, 1.5, 1.752. Okay, it was easier, I found, to mark the crosses on and then decide, right, I need the top of the rectangles either to go underneath, or I need the top of the rectangles to go up above. Okay, then it's a case of just finding the area of each individual rectangle. So this area, look here, it's got a width of 0.25 and it's got a height of whatever the y value of this coordinate is. So sub in 1.25 into the equation. Okay, so the first one here hasn't got any height, so it's 0.25 times 0. The next cross on the next rectangle would be 0.25 for the width times, and then that y height is sine a half square root of 1.25. And then you need to do the other points as well, 1.5 and 1.75. Okay, the height of this last rectangle is 1.75, and the original one was a height of 0. So this is your underestimate. This is your lower bound. Similar for upper bound. Okay, but your first rectangle will have some height. Your last rectangle goes up in height to the value of 2 here. Look, the x-coordinate is 2. So again, all of them have got widths of 0.25. Use the y values to find the height. Starts this time at 1.25, 1.5, 1.75, and 2. Then you work out those values using your calculator, and these are your lower and upper bounds for the estimates using rectangles. Okay, ordinary, or you could also, not in this question, but it's very common to use trapeziums instead of rectangles. And there's a formula if that was the case with the trapezium rule in the formula booklet. Okay, so there's no formula as such for rectangles when you do it with rectangles. But if it was trapeziums, you would use the trapezium rule from the formula booklet. Overestimate, underestimate. The shapes are above the line or the shapes are below the line. Okay, part B. Right, finding the integration of finding the correct integration by substitution. So we start off with a half, a sine square root x minus 1 with this substitution over here. So I'm squaring it to get rid of the square root, and I find out what x is. Once I've got the x, I can find out what dx by dt is. Take the dt up, so you're going to replace the dx with a 2t dt in here. Okay, there it is on the end, and inside that sin is a half of t. All right, so your integration, I think it was a proof question. It's the answers there on the question sheet. Integral 2t sin a half dt. Okay, question part 2. We need to do the integration. Let's hide that. Let's do part 2. Okay, so this is the integration that we want to do. Sin a half. We have just found that we can replace that integration with the one in part A, 2t sin t a half. Don't forget though, you must change the limits. These are x limits, so 2 and 1 become 1 and 0 when you change it into a t integration. Okay, so this has got two things multiplied together essentially in my integration. It's it's an integration by parts question. Now you've got a u and a dv dx. The u is always the power of the letter unless there's a ln in the question. So my u here is going to be 2t. My dv dt becomes sin t over 2. Okay, that one needs integrating. The 2t needs differentiating. Here's the formula from the formula booklet for integration by parts. So the uv is 2t times minus 2 cos t over 2, there it is. And then you've got the integration of v du dx. All right, just in there. It's got a minus here, and you've got a minus in the integration, so I'm bringing the minus out and making a plus in the middle. Limits are 1 and 0 on both of them. Left-hand side here should be quite straightforward. This one needs integrating. Okay, so a cos integrates to be a sine. The minus a half in there needs to divide when you integrate, but if you divide by a half, then it's the same as timesing by 2, so you're going to get an 8 in there. I think I said it one way around. Cos actually differentiates, so it integrates to be sin. Okay, subbing in the values 1 and 0 into both of them then. On the left-hand side, 1 and 0. On the right-hand side, 1 and 0. This would have a 0 in the timesing out because it's got a t in it, so that can be crossed out. This sin of 0 would be also 0 because sin of 0 is 0, and you're left with the 2 8 sine a half and the minus 4 cos a half as per the question.